So in this question right here, write down what we know. What do we know? How fast is the height of the rocket changing? How fast is the height of the rocket changing? It's right there in the question. How fast is the height of the rocket changing? 880. So we're going to say the distance, the height of the rocket changing is equal to the rate of change of the height of the rocket is 880, dh dt, where h is the height of the rocket at time t. H of t, h is the height of the rocket at time t. What else do we know? The camera to launch is how far? Camera to launch point is how far? It's right up there. 3,000. Everybody stand up. Nice. Excellent. So now let's draw a picture. We drew the picture before, so it was 3,000, a little bit higher like this. We knew it was a right triangle. 3,000 like this. So let's label. So no, and now let's label. Let's label. What variable do we want to use for the distance between the camera and the rocket? What do we want to do use for a variable from the camera to the rocket? We use c. So let's use c from here to here. What do we want? What do we want? What do we want to know in terms of c? What do we want to know in terms of c? If c is the distance from the camera to the rocket, what do we want to know? The rate of change. So how do you write the rate of change of c with respect to time? How do you write the rate of change of c with respect to time? Yeah. We want dc dt. We want dc dt. We want the rate of change of c with respect to time. So if this is what we know and this is what we want, we need to relate h and c. We need to relate h and c together. We know how to do that, Jen, because we have the Pythagorean Theorem. What's the base of our triangle stuck at? What's the base of our triangle stuck at? 3,000. So we know that 3,000 squared plus h of t squared is equal to what squared? Yeah, c of t squared. The distance between the two. The distance between the two. So we have related h and c. We've related h and c. So we don't have to write the t in there. We could write it as just h squared equals c squared. That's totally fine. But h and c are written in terms of t. That's relating h and c, but we want to know the relationship between the rates of change. We have a relationship between h and c. We want to know the relationship between the rates of change. So what do we have to do to this? What do we have to do to this? If this is the relationship between h and c. If we want the relationship between the rates of change, what do we have to do to that equation? We've been doing it for weeks. What do we do? Find the derivative. We're going to take the derivative in terms of t. We're going to take the derivative in terms of t. What's the derivative of 3,000?
0? No.
You don't know?
0.
The derivative is 0. You got it. Yeah, the derivative is 0. Okay. So the derivative here is 0. But that's okay. Oh, you know that h is what? What is h?
4,000.
Oh, because at what time is the question asking you to find the rate of change? When the height is 4,000. So we know h is what? 4,000. So we know it's 4,000 times 880 equals c times dc dt. Oh, you can't see anything, can you? Sorry. This right here. So what's the last thing we need to find? We found h, but what do we need to find now, Lizzie? We need to find c. Oh, we can find c, can't we? How do we go about finding c? Do you remember our original picture over here? We're looking at it when h is what? When what? When h is 4,000. Well, when this is 3,000 and this is 4,000, what's c? We already figured it out. It's 5,000. So we know that when h is 3,000, what does c equal? 5,000. So where do we plug in that 5,000? Where do we plug it in? For c. We just plug it in right there. So you have 4,000 times 880 equals 5,000 times what? dc dt. So what does dc dt equal? Before you simplify it, it's going to be 4,000 times 880 over 5,000. Can someone take out their calculator and do that for me right now? The derivative of that with respect to t, you're going to get 2b times db dt plus 2h times, does this look familiar, everybody? Does it look like what we just did? It looks like what we just did. But here's the thing. We know what, we figured out, we crossed out all the 2's, right? And then what did we plug in for? We plugged in for a lot of those things, right? We plugged in for h, we plugged in for c, and we plugged in for dh dt. What's b equal to? What's the distance always equal to in this case? What's the base of this triangle always equal to? 3,000. Is the distance of the base changing? Is the distance of the base changing?
No.
The length of the base. No. So what is dB dt? What's the rate of change of that going to be then? If it's not changing? 0. Oh, what's 0 times 3,000? 0. So that's another way to see that it's 0. The key for this question really are, for related rates, 3 things. What could we write down right now like we did before? The radius is changing at 2 feet per second. So what do we know? The radius is changing at 2 feet per second. D what equals what? Let's call the radius r. So dr dt is equal to what? 2 feet per second. That's one thing we know. How fast is the area of the spill increasing when the radius of the spill is 60 feet per second? What do we want then? What rate do we want? What rate do we want? How fast is the area? So what do we want to call area? What variable do we want to use for area? How about A? Let's call it A. So if the area is A, we know dr dt is 2. So what's the area rate going to be? D what equals what? Oh, what do we want? D what? dA over dt. We don't know what that is yet, but that's what we want. So if this is what we know and this is what we want, what do we need to link together? We need to link radius and what? Area of a what? What shape? Of a what? Of a circle. Do you know how to relate radius and area of a circle? You know what the equation is for the area of a circle? Do you remember? The area of a circle is what? Pi times r squared. What does it become? Differentiate with respect to time. Yeah, you do. Implicit differentiation, you definitely do. If A is written in terms of t, what's the derivative of A going to be? The front. So 2 pi times r to the first power, but then what do you have to multiply by? Yes, what rule makes it so you have to do that, Nick? What rule is that?
Product rule?
Careful, not the product rule. Chain rule, exactly, yes, perfect. Do we know some of this information already? Yeah, so we can take dr dt and put it in right there. So we have dA dt is equal to 2 pi times r times, what do I plug in? 2. Which one do we want? We want dA dt. So what's the only thing we need to figure out right now? What's the one thing we need to figure out? R. This is where we look at the rest of the question. What does the rest of the question say? When the radius is what? Hey, it even tells you what the radius is when you want this rate of change. So where do we plug in 60? Where do we plug in 60? For R. So we know dA dt is equal to 2 pi times 60 times what? 2. Times 2. So what's dA dt going to be? 240 pi.